As you know, we are working on dog breed detection with Bilge, Velid, and Mert. And now I will start with, if you remember, our dataset contains, with the other slide, yeah. If you remember, our dataset contains dog breeds and we use it to classify dogs. And there are 120 classes with 20,600 dog pictures, and there are an average between 170 and 180 numbers in each our class. I want to leave the word to Bilge to talk about the model before we get the mobile part.
I'm going to talk about our model. At first, when we downloaded our dataset, we had a file consisting of all images. We wanted to split this file as a train, validation, and test. Since our dataset was not sufficient in number, we reserved 10% for testing and 20% for validation. You can see our folder, how our folder looks like. Here you can see this code is about how we created our test folder. We used a Python shuttle module for this. If you ask me what is a shuttle module, it's an inbuilt model that comes with the automation process of copying and removing files and directories. We use the move function from this module. With move function, is used to move the file and directory from one directory to another directory and removes it from the previous directory. This is also same for validation data. You can see which libraries we used. Now I'm gonna talk about our model. We used a pre-trained model, Inception v3, for this data set. When we have a relatively small data set, super effective technique is to use transfer learning, where we use a pre-trained model. Transfer learning has made our job easier as it significantly reduces training time and requires much less data for training to improve performance. Inception v3 is a kind of convolutional.
Teacher, can I ask a question?
Yes, teacher.
Why target size is 299 by 299?
Because it will be our target size.
So how many classes do you have?
120.
You said?
120.
Why now you have 299?
Because it's shape.
What's target size? What do you mean by target size? The prediction?
When we send our because you know our model first layer is input layer.
Yes.
And output also.
Yes, in the end you are gonna output.
Yes.
120 real numbers as an array, right?
Yes.
As a vector of real numbers 120, but you are now 299 by 299. I didn't understand this. Where did you use this target size in the model?
Below.
Where?
Here, yes, teacher, here.
This target size is actually, I think, you are just changing the resolution of the images. You are changing the resolution of images. to this. Why?
We have different in our data set. We have different size.
Okay, I understand. But if you go to the model input layer, if you go to the model input layer, I think it's up.
Yes.
Now you see that it is all none, 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 none. So if you go a little bit more up, more, where is your model? Go up here.
Here, teacher.
Where is the
Inception.
target size?
I know the answer, but I can't explain. I think. Do you think it's wrong?
Here you see in the base model.
Yes.
When you get the base model, there should be some size information, right?
Yes, teacher.
You need to update this size information by the
when I
target size.
when
You
I
understand?
search Inception V3 model, it said that it automatically download. Maybe I thought maybe because of this, I didn't want to change it.
Okay, but you
because
need to give the model the input size. Okay, here you are just converting all the images to that target size. You are changing the resolution of each images, right?
Yes.
And you need to inform that inception model. I am going to provide you this target size, actually 299 by 3, right?
Yes.
And in the inception model, you provided the weight parameters, include the parameters, and you need to provide here the input size. Since you didn't provide the input size, if you go down a little bit, go down a little bit more. Now look at that. Input 1, input there, none, none, none.
You are right, teacher, but I thought I want to make this size smaller. That's why I choose.
Then you need to give this information to the inception model. Do you understand me?
Yes, I understand, teacher, now.
I am saying that. I am not asking you why you are updating the resolution. I am saying that if you decide to update your images different than 224, if you want to this different number, then you need to update with that information the inception model. You need to feed this information to the inception model before creating your model. Now your model can accept anything, any size. But you need to be aware of all this, what you are doing.
Yes, yes, teacher.
The last thing, the target size is not a good terminology. It's the image size. It is the image size, not target size. Your target is size 120, one of these classes. Am I right?
Yes, you are right.
Continue.
Okay, Inception V3 is a kind of convolution neural network model. It contains multiple convolution and maximum pooling steps. The final stage contains a fully connected neural network. This model will be downloaded automatically the first time the model build command runs.
Why did you use the softmax as activation function for the last layer?
Because teacher, the softmax is used as a activation function for multi-class classification problems. We are doing multi-class classification. It converts the output of the last layer in our neural network into what is essentially a probability distribution
Okay, bravo. Thank you. Continue.
Okay. Now I want to talk about 2D, as you can see, 2D global average pooling we used. If you ask me what is this, this pooling block takes tensor of size, input width, input height, and input channels, and it computes the average value of all values across the entire input width, input height matrix for each of the input channel. And you can see our activation function is softmax. Now I'm gonna talk about preprocessing we use.
Last question for you.
Yes, teacher.
Did you unfreeze any layers of the pre-trained model? Did you unfreeze any of the layers of the pre-trained model? Do you hear?
Yes.
Fine tuning or just transfer learning? What you do here?
In this code, teacher?
Yes.
I think this is not fine tuning. This is a transfer learning, teacher.
Çağatay?
Because...
Thank you. Çağatay?
Yes, sir.
So do you think that in that code, do you update any weights of the pre-trained model?
Update what, sir? I couldn't catch it.
Any weights of the layers in the pre-trained model?
Any weights?
Yes.
You said weights. I only know about global average pooling, the formula.
I am not asking about global average. I am asking that you have used the pre-trained model. Am I right?
Yeah.
Do you update the weights of any layers of that pre-trained model?
I don't know, sir.
You don't know. Mert Kemal?
I think we don't update them because in the line where it says base model is equal to inception v3 weights, we have a section that says include top equals false.
So do you think that, do you apply the transfer learning or do you apply fine tuning?
I am
asking Kemal.
I think we use both.
Both?
Yeah.
To apply both, you need to update some weights of the pre-trained model, right? Some weights. For example, last 2 layer, last weight layer, last 3 layers. But here, as we see that, you keep all the layers weights frozen, right? You didn't specifically tell the model that some layers trainable true. Am I right, Bilge?
Yes, I think yes, teacher. What I seen here, you see the weights ImageNet assigning the weight parameter to ImageNet because will enable the weights of the model that want the ImageNet competition to be used.
Yes, I understand this, but for example, if you want to update the last layer of that model, in the inception model, last layer, what you should have to do? You would say that last layer trainable parameter must be true. Am I right?
Yes.
So you are not fine-tuning the parameters.
Yes, we are transfer learning.
You are just transfer learning.
Yes.
Do you agree, Kemal?
I agree, teacher.
Yeah, I see now.
Yeah. Because otherwise you need to specifically tell that freeze these layers, unfreeze these layers. right? So trainable false or trainable true. But you didn't specifically tell this, so it means that all the layers are frozen. Their weights will not be updated during the train process. Am I right?
Yes.
Yes, yes, teacher.
So why did you choose this way?
You're asking me?
Yes.
Because with transfer learning, because it's pre-trained model, it trained with 1 million sample before. So with transfer learning, every time it remembered previous when it's while it's training, it remember the previous information or weights, and apply the next one. So it's easy to achieve the high accuracy with transfer learning.
Okay, but you need to try it and see that if a couple of last layers can be trainable, maybe your model can behave better.
Okay, teacher.
Okay, do you understand my suggestion?
Mm-hmm.
Okay, let's continue.
Now I'm going to talk about preprocessing. We used a image data generator. This allows us to randomly rotate, you can see rotation rate, rotate image through any degree between 0 and 360 by providing an integer value in the rotation range argument. Speaking of the range function, I want to talk about also a fill mode. When we image rotated, some pixels will move outside the image and leave an empty area that needs to be filled in. We can fill this in different ways, like a nearest or another things. But the nearest replace the empty area with the nearest pixel value, so it this makes picture makes sense. And the other parameters, it may happen that the object may not always be in the center of the image, because we have some pictures.
We can go over this part. Okay.
Okay, teacher.
Let's save time.
Okay. Now this is our model summary. Yes, model compile, optimizer, add-on. We use loss function, categorical cross entropy, because we are doing multi-class classification, and for classification metrics must be accuracy. Model fit generated. You saw we have created the iterations for augmented the images, but how we feed it to the neural network so that it can augment on the fly. We feed the iterator as an input to Keras fit generator method applied on neural network model, along with epochs, base size, and other important arguments. We will be using a convolution neural network model. This fit generator method fits the model on data that is yielded batch-wise by a Python generator. Teacher, we choose. I want to talk about epoch number also. We choose epoch 10 because after 10 epoch, accuracy will. I thought I saw that model will not learn, so we stop 10.
Bilge, have you heard early stopping?
Yes, teacher,
Have you
from
heard
you.
early stopping?
Yes.
you can use the parameter early stepping, right?
Mm-hmm.
Then it will monitor one thing, for example, validation loss or validation accuracy. If it does not improve, for example, if the patient is three times consecutive, then it will stop automatically. So next time, please update with that early stopping parameter using. Okay.
Okay, teacher. And these are for plotting. Now is testing. We use image data generator. Before we used preprocessing before testing. Now you can see our teacher evaluate accuracy loss value. I did a confusion matrix for final report, teacher. I don't think it's correct. I think I maybe made something wrong with labels. I don't know why it seems like that. Yeah, and now we rescaled.
Actually, it's not a good idea to print the confusion matrix for 120 labels, right? Classes.
Yes, but other people did. I wanted to try it, teacher.
Yes, but there is something wrong in your code, I believe. Okay.
Okay.
But the classification report must be much more useful. Huh?
Yes.
Let's see it.
We rescaled. You can see the different metrics here. And then finally, you can see our results for testing. We almost reach I think perfect. I don't know. Maybe you find not perfect, but
okay. Can you go a little bit top for the classification report? If you check the F1 scores for the classes, F1 score, which one is the minimum one? The lowest score.
Lowest score maybe.
You need to check these, okay?
Yes, teacher.
And you need to then understand why it is so low. You need to check this, okay? And you need to check the confusion matrix for that one. For example, see that there are 10 images, but the F1 score and the precision and recall is very, very low. So you need to understand the problem in that class. You need to focus on that and you need to try to solve this. If there are more classes like that with very low values, okay, you need to pay attention to this class, open the folder, check the folder. If there is a mistake, blah, blah. Do you understand this?
Yes.
Okay. Do you conclude?
I'm open for any question from you, teacher.
Thank you. Let's continue with your presentation, Lear.
So hello, I am Mert. I will give some information about the mobile application part. Again, our dataset is a dog image dataset. We started to develop the application on Flutter first, but then we decided to have an Android Studio application as well, since there were better documentations to learn how to deploy the machine learning model on an application for Android Studio. So we have some screenshots for both of them. In both applications, we have our project logo as an image view object. Other than that, we have two active buttons. The start and camera buttons are used for activating the camera to make it ready to take a photo and send it to the model. the application asks for permission to use the camera first. Then if the permission is given and the camera is activated, it shows a little information message. If the permission is not given, it pops up an error message. Secondly, the gallery button takes the user to the phone gallery to pick a photo and send it to the model. Then the application prints the results as dog breed name and the confidence rate below it. We also show the thumbnail of the selected photo on top right.
Kemal,
Yes.
to access the gallery, you need to request the right. Otherwise, it cannot give you the allowance to access the gallery. Am I right?
I don't think it needs permission to access the
No?
gallery. Yeah,
it's given automatically.
It did, yes.
Or when you install the application, maybe.
I mean, it asked the permission for the opening the camera, but it did not ask a permission to open the gallery in our application, at least.
But it will ask the permission while you install the application for your telephone.
I think so. Okay, continue.
We also showed the thumbnail of the selected photo on the top side of the screen by setting the application logo to the selected photo. The saved model is firstly transformed into TF-Lite model, and the TF-Lite model is directly implemented to the application along with the label text file. We have not managed to transform our model to TF-Lite model yet, but we tried a ImageNet model, a pre-trained model, to test our application.
Why not? Why couldn't you?
I don't know.
Because we have an issues on Flutter and we turn to Android Studio now. It's going well now. We will do it in a few days.
Okay.
Yeah, that's it. Thanks for listening.
So you don't have any demo?
We have a working application, but it does not contain our model. It uses a pre-trained model.
Dummy model.
Yeah.
Okay. Anything other to tell or to report? Do you have anything to report more?
Thank you, sir.
So actually in that presentation, I would like to see how it works.
Yeah.
Okay. So I hope that, or I expect that you can convert your model to TF-Lite or whatever the technology you use. And you should be running this on a smartphone or tablet, whatever, a mobile application.
Yeah,
but you should do it, okay? In a couple of days, do it, okay?
Yes.
Yeah, don't worry, sir.
Okay, thank you.
Thank you.
Thank you for listening.